Great. Okay. Thanks very much. So, as I'm going to turn my pointer into a laser pointer. Right. There we go. So this is a slight repeat, but the yeah. So I won't say what Helen just said, but a couple of recent diagrams from a recent paper in Science that includes Salim Ali from the Sustainable Minerals Institute, just looking at future demand for a range of different critical minerals. Where on the left-hand side here you can see that's current demand and the additional demand into the future, and a map showing where these different critical raw materials are. And as you can see in this map, as of this data set, Australia wasn't on that list, but as Helen pointed out, we're increasing our efforts in this area. So what's the rationale behind the project that I'm going to be talking about? And really the first thing to say on that front is that non-competitive data sets that are being used by exploration companies all over the world, and certainly in Queensland, they play a vital role in exploration success. And when you look at the Northwest Mineral Province, for example, but the rest of Queensland as well, there's a whole range of non-competitive data products that are available, mainly focused on the more traditional commodities like copper, gold, coal, silver, et cetera, et cetera. An example of that would be the Northwest Queensland Mining Energy Program study from 2011, which was a huge compendium of non-competitive information that includes geology, geochemistry, geophysics, a whole range of different things. As well as there have been studies that identify areas of interest, defined on the basis of a series of criteria gleaned from mineral process models and other sources. And so the impetus behind this project is that really there's, with this increased focus on new economy mineral commodities, there's a need to produce a similar set of products to aid explorers in area selection and their discovery objectives. In fact, there's an even greater need because speaking for, I know that for many of us who've spent a lot of our career exploring in the more traditional commodities, there's probably less knowledge even of the mineral deposit models and the approaches that you would use to target mineralization of this different style. So just a little bit more on that. So a photo from which I didn't think it was that long ago, but it's actually 18 years ago. A bunch of geologists from MIM Exploration looking at an outcrop near Century. And then on the right-hand side, the whole range of different regional data sets that we have available to us if we're going out looking for copper or for lead, zinc, and or gold. And when you divide those up into the sort of approaches that you would use to carry out target generation for area selection, we'll leave aside direct detection for a second, just think about area selection. And one of those approaches, and it's one that I'm sure a lot of people in the audience have been involved in, is what you would say is maybe a process model driven targeting, where on the left hand side here I'm showing something actually from a study that was done even earlier, around 2000, led by SRK, but it involved a number of people like Vic Wall and Mark Hinman, putting together a process model for a range of different styles. Here we've got lead, zinc, silver, metasediment-hosted ISA style copper, magnetite-rich, hematite-rich copper, gold, and so on. And areas of interest that have been defined. And if you clicked on one of those polygons, you would come back with a series of criteria where you could assess what the person had used to identify those areas of interest that and take it or leave it essentially, or change the weighting. Or there are also a whole series of products around that have been developed, and these are a couple from recent or last 15 or so years studies in the Eastern Succession in Mount Isa, weighting prospectivity based on a whole series of lines of evidence and producing using weights of evidence in this case to come up with a picture of prospectivity. So you know, that's one angle of regional targeting, but the other one, of course, is data-driven targeting. So using raw data, and what we're looking at here is a color categorized mineral occurrences or exploration geochemistry, and in this case, we're just looking at copper in stream sediments with different percentile thresholds, or even just geophysical anomalies. Or you could do some sort of data analysis, and I'm showing a really simplified version of some data analysis that you might do. For example, mineral occurrence density. So this is in this case is the density of copper occurrences, basically just color contoured, or treatments, you know, various different treatments of water geochemistry. And traditionally for exploration, we'd use these two sorts of things in tandem to identify regional areas that we might want to target. And what we do in that area for critical minerals, well, first to just say a little bit, I'm not going to say much about this because Helen's covered some of this, but there's a whole range of different elements, some of which are traditional, some of which are new, that cover, you know, photovoltaic cells and you know, wind power, batteries. And again, I'm not going to spend much time on these other than to say that you know, there are a well identified set of elements that we're after. And even if you start to consider decarbonization, this is from the Dow Center, where they're basically looking at supply of all these different elements here and the effect of variations in supply of those different things for decarbonization. So what's the approach that we can use for targeting of new economy minerals, because that's basically what this project is about. And the first thing you notice is that when you take the list of new economy minerals that are on the website associated with this new initiative, and start relating them back to process models, there are nearly 70 different process models that you could consider to be applicable to those commodities, which is obviously a very large number. But what you see as well is that, of course, there's a significant overlap in terms of both commodity and geological factors. And when you start considering the process, you soon realize the ludicrousness of the number of different process models we come up with. And it's certainly possible to reduce this to a much more sensible number. And the other thing that comes out when you look at the list of new economy minerals that might be of interest is that there are two broad groupings. There are those that occur in standalone deposits, like tin tungsten, to a certain extent, like rare earths and others. And then there are those that are really almost always as accessories to other commodities, like gallium in zinc deposits. And so in this project, we're really treating those differently, both from a point of view of compilation and consideration of prospectivity. And so really the aim of this project is to produce a suite of similar to the ones I showed before, non-competitive geoscience products which will aid exploration for new economy mineral commodities. Just checking to see how I'm doing for time. And really this is a staged project. So what we're initially focusing on now, running up to September, is developing a couple of prototype compilations for two selected commodity groups, one predominantly primary, and I guess topical in this case, and one predominantly secondary. So we're doing our initial prototype focusing on rare earths as the sort of primary commodity, though I know it does often come with other things, and a predominantly secondary commodity we'll be focusing on will be cobalt. So the project commenced about 2 months ago, when I thought about this, you know, in the last few days preparing this presentation, I thought, gee, mid-March seems like a hell of a long time ago now. I guess it's one pandemic ago, yeah, so it's still very early days in the project. And so we're actually going to hear today about some of the information that is probably going to help us constrain our process-driven targeting. So, you know, when you think about some of the process models you might want to build, and the aim of this step is to basically turn the understanding of process into a series of spatial areas that might focus exploration. So our aim isn't to redo the process models, it's much more to take the ingredients of the process models that allow us to put together and disseminate areas of interest on the ground. That you might have the, I've got a very long title for this one, the IOCG/Mary Kathleen style uranium rare earth multi-element systems, where Ken Cullerson recently has proposed, interestingly, and I think, you know, with some merit, an analog with the Idaho Cobalt Belt, where, you know, we might sort of be, where we can, you know, the aim there is to take the key ingredients for that and produce a spatial picture of high priority areas. We're also going to hear today about sedimentary phosphate. So I've got a map here from some work we've done previously, just showing phosphate occurrences of different types in the Queensland side of the Georgina Basin. Magmatic rare earths, so the Peak Range, and I think we're going to be hearing about that today. And Ken again has previously written reports on the so-called Diamantina province, which is certainly, I think, again, worth putting together into a spatial coverage of potential target areas to constrain further exploration. And then Carol Spandler is going to be talking about unconformity related rare earths, the best example of which so far is not in Queensland, but it's still a model that we consider. And then there are other opportunities that are, I guess, less in the exploration realm, around mineral sands, bauxite residues, and even coal waste, some of which Kate Tumpelainen is going to talk about because they're processing opportunities, if not exploration opportunities. And one thing I wanted to bring up was because of the fact that there's been so little focus on some of these commodities, the one question I asked myself early on that I just wanted to sort of throw out there was, you know, has the next rare earth deposit in Queensland already been found? You know, I've mentioned already there are two different opportunities here. There's the geology-driven targeting, where you're coming up with a process and saying, what are the spatial implications of this process? And then there's the data analysis-driven side of things. So talking about the data analysis side of things, you know, you might look at the Queensland mineral occurrences and say, well, there's a lot of, you know, there's been a lot of occurrences noted out there, and if you take the rare earth-bearing mineral occurrences from the publicly available data set, there's 15 in the publicly available mineral occurrence data set, and if you include other data sets, you get a few more, but not too many more. And one of the things that we've done early on is to actually take there's a global, probably some of you be aware, there's a global USGS database of geological characteristics of rare earth elements around the world, that includes a quite comprehensive list of mineralogy. And if you take that list of rare earth bearing ore minerals from all those different deposits and filter out the really common ones, so that you're not really biasing the data set, you still end up with a much larger number of occurrences that have similar mineralogy, that haven't been recognized as rare earth deposits, or potential rare earth deposits, keeping in mind that there are very, very few actual rare earth analyses in the whole data set, as you'll probably hear from Vlad later on. So that's something, just a little bit on the, how am I doing for time? A little bit on the approach that we're going to be taking on a primary commodity in rare earths. The other one that I wanted to mention briefly that we're going to be focusing on for as a secondary mineral is cobalt. So we've got on the left here a GSQ map, just again taking mineral occurrences, showing cobalt occurrences, and on the right-hand side here, including the S&P cobalt resource data, and I've added in a rough estimate based on information on the average grade of copper mineralization, or the average grade of cobalt and copper mineralization from Mount Isa, which is, you know, a little under 0.1%, and you end up with a rough cobalt endowment for all of Queensland, about 450,000 tons, as compared to an annual world demand of about 290,000 tons. But the interesting thing is that when you look at cobalt in these sediment-hosted base metal systems. And this is another example from my favorite rock that I talked about a few weeks ago. We've done a higher resolution, more multi-element scan of some of the material from there. And what I'm showing on here, that's about a 2 centimeter width there, is copper distribution, iron distribution, zinc distribution, and cobalt distribution. What you can see right away is that any consideration of cobalt resources in these sorts of systems needs to take into account that cobalt doesn't actually correlate terribly well, or at least at first glance in this sample, with the ore minerals. It correlates much better with pyrite. And when you look at these systems, if you were considering the size of the pyrite system, and considering the possibility that within there may be high-grade areas or areas of higher cobalt concentration, there is a chance that that some of these systems may contain world-class cobalt resources that we're not even aware of yet. So it doesn't correlate one-to-one with base metals. And there's the question that one might ask is, are those cobalt resources much larger than we think? So what I do want to talk about is just a little bit on the outputs that, because we're really only, a little bit more than a couple of months into this project, I don't have a huge amount of outputs to show you, but the outputs that we're planning to put out are a literature review and classification of new economy mineralization styles and process models for the commodities that we're focusing on, in comparison to some of the other efforts in this area, to extract the key mappable geoscientific features derived from those process models, and to incorporate those into regional geological, geochemical, geophysical occurrence information to develop spatial maps of areas of interest for the commodities in question. And in those areas of interest, to include data fields that will set out the rationale for their identification so that people can make their own reprioritization if they want to, and deliver those in fully attributed GIS coverages, as well as a PDF report, and to deliver the best possible sort of online tool that will allow people to apply their own selection and weighting of target criteria to some extent. And Richard and his team at GA have been real leaders in that. So we'll be doing our best to try and steal some of their ideas, fully attributed, of course, and to stage a workshop to present the results of that study. So the other thing to point out before I finish up is that obviously we're working in a context where there are a number of other projects going on. So you'll be hearing today about projects from Adelaide Uni, James Cook, ANU, and GSQ, focusing on the development and refinement of various different process models. And our goal really is to distill the key components of those studies relevant to regional targeting. So the way I'm looking at it is, we're not here to do the super detailed high level geological work to re-prosecute or reformulate those process models. We're there to distill those, to do very much what you would do in an industry-led regional targeting exercise, which Paul and I have both been involved in many of, where the fundamental outputs are GIS layers and data deemed relevant to the commodity, layers setting out the area of interest, and additional focusing information as I previously detailed. So that covers what I wanted to say. Thanks very much.